I would like to introduce Professor Catherine Tucker, who is the Sloan Distinguished Professor of Management and Professor of Marketing at MIT Sloan School of Management, as well as a co-founder of the MIT Crypto-Economics Lab. Professor Tucker's research, published in top-tier journals, has centered on data and algorithms, online advertising, privacy regulation, and the impact of digitization on competition and consumer behavior. Professor Tucker's vast expertise in the economics of digital technology has also made her a highly sought-after advisor and speaker for international organizations, governments, and businesses, including the IMF, International Monetary Fund, and the Director General for Competition of the European Commission, among others. Professor Tucker has received numerous awards for her academic research and also teaching, being named the Teacher of the Year at MIT Sloan, and students highlighting her engaging classes and sharp sense of humor.
So, first of all, I'm going to give you a little bit of a backdrop to how AI and machine learning is used in the world of marketing and data. And I'm going to talk about two different ways it's used, both for consumer markets and what we call business markets when you're selling to businesses. And then I'm going to say, well, this actually tells us when we take this area, it's going to tell us a lot about something I call algorithmic exclusion, which is how algorithms can often inadvertently exclude those who are most disadvantaged in society. And once we've done that, then I'll try and say something provocative to ensure that you actually have something to ask me about at the end of the day. All right, let's get going. And what we're going to do is I'm going to start off with the paper which started me off in this line of inquiry. And it was a paper I wrote with Nico Neumann, who is a professor at Melbourne Business School, and Tim Whitfield. Now, Tim Whitfield is an amazing co-author in that I don't know about your co-authors, but Tim Whitfield's one of my favorite ones because I've never met him. I don't even know his email address. I've never spoken to him. So why is he a co-author? He's a co-author because at the time we wrote this paper, he was one of the most powerful men in Australian advertising. And basically, we only got to get access to this data in insights because Tim basically controlled billions of dollars of advertising spending and threatened to withhold it if they didn't help us with the study. So great co-authors here. Now, what we did in this first paper was we went to ask, well, when you think about AI, when you think about machine learning, a lot of the use cases, edge cases end up being in marketing. Why is that? Well, I think in some sense, data is easy to come by in marketing. There's not too many, shall we say, rules, regulations getting in the way of deploying AI. So it's a good place to examine how AI is being used. And what we're going to be doing is we're going to say, given that this is an area of the economy where we see AI being deployed a lot, how well is it actually doing? Is it doing good things for advertisers? Now, another reason this is going to be interesting is because a lot of the data collection which goes in to feed these machine learning algorithms is exactly the kind of data collection which Rose Europeans has been regulated by GDPR, will be regulated by the various Digital Market and Service Acts. So it's very much a policy question too, given we're collecting all this data. How well are we doing at parsing and deploying it? And I'm going to be looking at a sector of advertising, which is what we might think of as the online advertising. And this is the world outside Facebook and Google, where if you go, for example, to a website like ESPN, it's how the advertiser knows what ad to show to who. And we're going to be talking about that long tail of the internet, the ads that are shown on it, and how machine learning is used for those kind of ads. Now, when I started off in this field, I had always assumed that when advertisers were buying predictions made on data, they were buying something vastly complicated. for example, who is it who's going to buy that orange sweatshirt yesterday and in what size? You sort of think it's going to be incredibly detailed, but that's actually not the kind of data segments that advertisers are buying online. Instead, a lot of the data that advertisers are buying online is really very mundane. It's about people's age, it's predictions about people's gender. And so what I'm going to ask in this paper is, given that advertisers are buying predictions about age and gender, how well is this data economy, machine learning economy doing at predicting age and gender? Now, a natural question is, well, how is it that data brokers know age and gender? Well, you're going to make a prediction from someone's browsing behavior. And you can imagine how you might do this. Maybe if I look at a tampon or sanitary products website, you might predict I'm a female. Maybe if I look at retirement homes, you might predict I'm old. But hopefully you're already seeing the problem, right? This is actually a very difficult prediction age. Ask. And I know we can't see everyone's faces on this call, but I would like you to sort of imagine everyone's. How easy would it really to be able to distinguish who's a woman, who's a man, who's older, who's younger? It's actually a very hard prediction task. And I want you to have that in mind before we go forward. So we're going to be asking how machine learning is doing at predicting age and gender. And the way we did it in the first study is that we recruited about 35,000 people, and we asked them in survey their age and gender. It was that simple. And then we went to a data broker and said, tell us what age and gender you predict this person is. And we're going to compare the ground truth from the survey to what the data broker told us. Now, you might be worrying at this point about selection because you're like, I would never sign up for this survey. You'd have to be crazy to sign up for the survey. What I'd say is, yes, I'm not saying that the people who signed up for our survey are necessarily going to be representative of the population. But what I would say is, in some sense, they should be the easiest people in the economy to make predictions about. I mean, if you're signing up for a survey to be tracked across the internet, you're not going to be using ad blockers. You're not going to be using Tor. You're not going to be using any ways of masking your IP. It should be easy to make predictions about you. So we're giving the data brokers, I would say, an easy task due to this selection. And what we really did was we even made the task simpler. We said, is this cookie attached to someone who's a man? And are they in the 25 to 34 age bracket? So it's very much you get it right or you don't as a question. Now, this is how the data brokers did. And let me explain this table of motivation for most of my work here, which is we have on each of the rows a data broker. And remember, each of our data brokers is making a prediction for that advertiser. And you should think of these data brokers as basically spanning the universe of data brokers. They're all the big multi-billion-dollar companies. They're all the data brokers attached to credit bureaus. It's really just about every data broker, apart from very few small ones. Then the final column tells us what percent of times they got the gender of that cookie correct. And so if you look at row A, 27.5% means that around 25% of the time they were able to correctly identify that cookie as a man. Now, what I want you to do, your first mathematical challenge, is going to be to take an average of that gender accuracy column. And when you do that, you're going to get to around 50% on average. And when you think about it, that's quite funny to be able to predict gender right half of the time, right? So let's be clear. These data brokers are doing basically the same as chance. You're guessing people's gender on the internet, they're doing about the same. The other thing which is interesting and important, I think, from this study is just that when you look at the number of cookies, which is the number of people that the data broker made predictions about, you might expect, given what we tend to think about data and how important it is, that there'll be a correlation between the number of pieces of data and how accurate the data is. But let me tell you, you can see here absolutely nothing in the way of correlation. That's your sort of second mathematical challenge. But if you try and correlate the second and third column, you're just not seeing anything. Which is, it was natural to us. We thought in our second follow-up paper, we should understand what's going on. How could it be this bad? And there's two explanations. Number one, it's something to do with the data brokers themselves. Another explanation lies that maybe there are people where the predictions tend to be worse. And so we were going to try and tease apart these two effects. We start off naturally, I think, because we're sort of business school people on the firm side. And on the firm side, we did the first thing any economist would do, which was to look to see, well, is there a correlation between how well these advertisers are performing and how well and what they're charging, because that's usually what you expect to see in a market. Now, let me explain. I know you're not economists, so let me explain the numbers in front of you and what they mean. This is a result from a regression. And in this regression, the dependent variable is now, did the data broker go on to get a prediction correct? And this is a whole new data set, which poor Nico spent 3 months slaving and collecting. We lost Tim Whitfield. Nico went out, worked with these firms for 3 months, got us this data set. And so we now have more predictions. We've got predictions about age, gender, location, hobbies. We have a lot more predictions in place. And what we want to do is we want to try and understand, well, are they, and we're using the same methodology with the ground truth provided by the survey. And what we're doing here is we're just saying, well, for the predictions which these data brokers are charging more for, do we see them be more accurate? And initially, if you just have a raw correlation in the data, it looks great. There's a positive correlation between price and how accurate the prediction is. But then when we investigated further, that correlation just disappears when you control for the type of prediction. And in this economy, it turns out that the cheapest predictions of age and gender, they're pretty much commodity products, they tend to be the ones which are worse. So the lowest price ones tend to be attached to the things which are most difficult to predict, whereas there tends to be a higher price for things which are easier to predict. And what would be an example of something which is easy to predict? It's whether someone in Australia likes sports. Let me tell you, everyone in Australia likes sports. You just say yes, you're going to make a good prediction. They charge a lot of money for that prediction. So you get this false correlation in the data. But we just didn't see in this industry what we expected, which is firms charging a higher price for a quality product. So then we went in, and this table is completely unreadable. So let me explain what we then did, which really gets the question, which we then said, is there anything distinct about any of the data brokers which looks like they're doing better predictions? And we ran what we call a simple fixed effects model, where we just said, are there any real differences between these firms? And we found nothing. We looked at how big they were, how old they were, their revenue. We just basically looked at everything. We just didn't see any systematic correlations. The only thing which I will share, given the title of the seminar, is that we did find a weak correlation in that if the data broker said they were doing machine learning, they tended to do a little bit better than if they said they were using AI. But you know, that was a marginal significance result. But I always thought it was funny. It does sort of suggest that AI is sort of misused in this industry as a term. Now let's get to the bit which really excited me though about this paper. And what really excited me about this paper in the end was obviously there's nothing really different about the firms. They all seem to be pretty bad at doing this job. Instead, what's interesting is who they are particularly bad at doing this job of prediction for. And in our new survey, we collected a lot more data about the people themselves to try and understand, well, who in the economy are data brokers able to make better predictions about? And in this table, what you see is some regression analysis we did, which linked this up to socioeconomic status. And what we saw was pretty systematic. People who have a higher income, people who are a college graduate, people who all of these things mean that data brokers make more accurate predictions about you. And so in the reverse, what that means is those who are lower income, those who have less education, those people who are renting, they tend to have far less accurate predictions made about them in this world. And this struck us as very interesting. We tried to tease apart an explanation for it. And let me give you two alternative explanations. So one explanation is, why might it that rich people have better predictions made about them? But one hypothesis is that they just generate more data. If you think about people like me, university professors, what do we do all day? We just generate data. We spend all the time online generating data to pass predictions about us. And contrast that with a blue-collar worker or a manual worker, they're not creating data. Another explanation is that someone like me, I've had my email address at MIT for 18 years now. I've had my phone number for 10 years now. This also means that reflects the relative economic stability of my life. And what does it also mean? It means it's easier to piece together data about me. Because remember, data brokers are trying to piece together bits of data about you from different sources. And if they can do that using a cell phone or a phone number or an email address, it's going to be that much easier for them. So we have these two hypotheses. I think both are probably true. We found somewhat stronger evidence for the identity fragmentation story, in that it was particularly demographics that these data brokers did poorly on for lower income people. That is predicting people's household size, their location, their age, their gender, all the things which are probably easier to do when you can piece together data. So we had some evidence towards it being about identity fragmentation, and the idea that if you're lower income, because you're going to be having a lot more economic instability, you're changing your email address, you're changing your physical address, you're changing your phone number, it's just harder to piece together data about you. Now, I'm not going to bother you with this, but some of you, if you've got a statistical bent, will be looking at this table and going, oh my gosh, that's just too simple. Do I believe it? And so you'll be glad to know that this is going to be a paper which is going to be appearing in Management Science. And as Management Science review process, we ended up doing a lot more tables, which were a lot bigger, basically showed the same thing. The table I'm going to show you is the accuracy of being profiled. And what you can see there is actually there's just nothing. The number of segments or number of predictions you're making doesn't seem to matter. If anything, if you're trying to profile more people, that's negatively correlated with how well you're doing in terms of accuracy, but that's a sort of marginally significant result. So we just don't see the size effects we often hypothesize. Where we do see an effect of size is if I then go on to just saying, how likely is it that the data brokers said they had an answer for us in terms of these demographics? Well, then guess what? You do see a positive correlation, but that's sort of to be expected given how we constructed the data set and sample. Anyway, I've actually got some more results, so I'll just get onto those. And I want to apologize too to the co-hosts, because as economists, we're a very, very rude discipline. And as a result, we're constantly interrupting each other. And so if I keep on pausing for questions, it's because I'm expecting people to start shouting insults at me. So we'll save the insult shouting to the end, but that's just the norms of the economic discipline. Now, with that said, let's get on to the results, which I think hopefully will be quite interesting, because one of the things that happen is management science, it's a big management journal. If you're a business school professor like me, we went through a round of revisions. They were like, okay, we believe the result, but it's not interesting enough. And that was really devastating to poor Nico, who's up for tenure. And so we were like, what do we do to make our paper interesting? And the answer was we found some new co-authors. And it happened to be that our new co-authors had written a paper which they were thinking of submitting to a computer science conference. And actually was asking a very similar question to us, but in a different context. And so we joined forces to try and make the paper interesting. And so what does this mean? It means that my new co-authors deserve all the credit for the next study, which I am now presenting. And what they did was really interesting. So something I never knew about America is that in certain states like North Carolina, all voter records have an incredible amount of personal detail. So as a voter in North Carolina, you self-report your race, your age, your gender, alongside your name and address. So basically, there's perfect data about each person in North Carolina who's voted out there. And what my co-authors did was they took 9,000 of these records, and they made sure they had ones that had been just recently updated, so the data couldn't be stale. And they simply uploaded these records in terms of a name and address up to a leading data broker's website. One thing I love about their study is they literally paid 0.015 per record for age information. So you can do your math and you'd suddenly realize this is a very cheap study to have run. So I think it was very brilliant because like Nico and I spent so much money doing our study and they managed to do it for hundreds of dollars rather than tens of thousands. And what they basically asked was they said to the web broker, what's this person's age? Now, the reason this is genius is because, of course, they know that person's age. It's in the voter record. And what's more, the data broker should know that person's age because it's literally out there on the internet. It's not that hard. It's not even a prediction. It's just, do they know it? And so then they went on to see how they did. And because we're now in the US context, when previously the studies I was showing you from were basically countries like the UK, Australia, New Zealand, and we're now in the US context, of course, when you're in the US, you're going to ask questions about race, because that's very much embedded in questions of socioeconomic status and privilege. And we're going to be able to focus on that. Because remember, the voter brokers told us what race each of these voters self-reported as. Now, this is what we found. And remember, the question here is, do they get the age of this voter record right? And we tried different bands. This is quite, you don't have to get it completely right to be yes. You just have to get it sort of right in the right zone to be yes, to make it. We don't make it too hard for the data brokers. Now, what you can see here is two things we think is important in the study. The first is what we've been talking about so far, which is, did they get the data accurate? But what was actually even more interesting to me about this study was, did the data broker have a record for this person? And I want you to see this. By far, the data broker, I'll show the regressions, this is all statistically significant, the data brokers were far more likely to give an answer for white people. The next most likely for Black people, and they were pretty unlikely, relatively, to be able to give any kind of answer for Hispanic people or Asian people. And this was mystifying to us, and we've done some research, and what we think's going on is this. Remember, the data broker had to match up name and address. It so happens that Hispanic names and Asian names tend to have be far more frequent, or there tends to be bigger overlap. And as a consequence, what our hypothesis is that the data brokers just struggled anytime they had two people with similar sounding names and just failed to be able to match them and didn't give a record. But if you think about this, this is really quite a big result, because remember, these data brokers, they're not just giving data for advertising. This is what would happen if we were having something like a housing background check. So if you're renting an apartment, what this is saying, and the landlord's trying to get a background check, is saying that if you're white, they're probably going to be able to get data for you 70% of the time. But if you're Hispanic, they're only going to be able to get data for you 54% of the time. And that seems to me a really significant difference, economically significant difference in terms of how much data is available about each person. Now, the other thing to say is we found these results, which was disturbing. And then the other disturbing result we found was also that though for this particular task, because it was public data, the data brokers tended to do a lot better with accuracy, it was still the case that they did worse for Black people in terms of being able to actually correctly predict their name, their age. And we link this in the paper back to a literature in finance, which shows that Black names often misspelt, often mistranscribed, and that we think could be the explanation of why it is that we see the Black names, the individuals who are Black, end up with far less accurate data about them. Now, those results are most striking. Remember, we definitely had race because people self-declared race. Because race is so linked in America to income, we actually see the same results as we saw elsewhere, and saw again that when you rank profession, it's the case that people poorer tend to have less accurate data about them. Okay, with that said, so that's the big result. We see this huge interaction between how the data economy is working and how inequality works. I want to get to some provocative conclusions. So what we show in this sort of series of papers is that black box profiling is working poorly. We're very excited. We're very excited about machine learning. We've got large language models. It seems incredibly perverse to me that we're still in this world where we find it very hard to make accurate predictions. We don't see any of the correlation we were expecting between firm size and how good they seem to be at deploying machine learning. I think that's comforting. I think we've seen it perhaps in the race of large language models too, but it does seem that there's not the hypothesized link between data and ability to do machine learning, use or deploy machine learning algorithms well. For us, the big result was this result about inequality, and the fact that we show that profiling and making predictions about people, it seems to actually, the ability to do it seems to very much rest on people's socio-economic background, and that's disturbing. So let me get into my provocative conclusion I'm going to draw is that I, as a researcher, spent a long time, a lot of my career thinking about privacy. But in the end, I've come to think that when you're thinking about privacy, that may be a rich person's concern. In the end, what we see in all these studies is that rich people, in some sense, they should be the ones worrying about profiling because they're the ones who are having accurate predictions made about them. Instead, if you're low income, the big question seems to be, I'm in a data desert. I seem to be excluded from this data economy where predictions are being used to make decisions about me. Is it the case that we should be worrying about data deserts rather than just privacy? The next point I want to make, and this I think will be provocative amongst AI researchers, is that, as we all know, in AI in general, we are obsessed about fairness, bias, trying to think about it. And that makes a lot of sense, right? We're worried about a world where a training data set teaches an algorithm to be biased or picks up bias that exists or so on. But my research is saying, actually, there's something else we should be worrying about, which is really boring, mundane, but I think important, which is that ultimately the data which goes into any algorithm is going to be messy, is going to be fragile, is going to be sparse. And if the data is not working, then we don't even ever get to that data because the algorithm just doesn't end up producing a result for that person. And so it's this idea of algorithmic exclusion, or the idea that algorithms just aren't making predictions about certain people, which I want to popularize and highlight as being a real concern, in addition to the obvious concerns about algorithmic justice. So with those two provocative conclusions, I will say thank you